Calvin is selling tickets to some of his soccer games. For the first game, he sold 3 adult tickets and 1 child ticket for a total of $38. For the second game, he collected a total of $52 by selling 3 adult tickets and 2 child tickets. What is the price of an adult ticket and the price of a child ticket? For us to solve a system of equations given to us in the form of a word problem, we first need to identify what are the variables that are changing and what we're solving for. So we're looking for the price of adult tickets and child tickets. So it doesn't really matter what variables we use. We could use X and Y, A and B. I like using something meaningful to the problem, so we'll call adult tickets A, child tickets C. Now we need to go back and see if we can come up with the equations that we're going to use. So if we take a look at this second sentence, it says he sold 3 adult tickets and 1 child ticket for a total of $38. So if we're going to write that as an equation, we can write that as 3A, since we have 3 adult tickets, plus 1 child ticket, and that totaled $38. If we continue reading, we can get another equation from this next sentence. It says we have a total of $52 by selling 3 adult tickets and 2 child tickets. So if we're writing our equation here, we have 3A plus 2C equals 52. And we have our 2 equations. If we take a look at these equations given to us, seems that the method of elimination would probably be the route we would want to take. Notice our constants in front of A are already the same, so if I were to subtract the second equation from the first, C, that would go away, and then we have 1C minus 2C would give us negative C. 38 minus 52, that's negative 14, so we get C to equal 14. So remember, C is the price of a child ticket. To figure out the price of an adult ticket, we're going to take 14 and plug it back in. It doesn't matter which equation we use. I'll plug it back into this first equation. 3A plus 14 equals 38. So by subtracting 14 from 38, we'd end up with 24. And then dividing by 3, we'd end up with 8. So A equals 8. So C equals $14. A equals $8. Grace is going to fly a plane 560 miles each way to the magical land of Ohio and back. The trip there was with the wind and it took 7 hours. The trip back was into the wind and it took 14 hours. Find the speed of the plane in still air and the speed of the wind. So if we're going to set up some equations, we first want to identify the variables that we're solving for. So the 2 variables that we're looking for that are changing are the speed of the plane. Let's call that P. And then also the speed of the wind, which I'm going to call W. Excuse my penmanship. So if we take our plane and we know we're traveling with the wind, our speed will be our plane speed plus our wind speed. And if we're going against the wind, we'll be subtracting that. Now, identifying what each of these equations are equal to, it might be easy to think about what units of measure these are. If we're talking plane speed, wind speed, if we look at the units that are given to us, we have miles, we have hours. So this is in miles per hour. So whatever we have over here also has to be in miles per hour. So in our first equation, when we're traveling with the wind, we're traveling 560 miles, and that took 7 hours. In our second equation, it was still 560 back, but this time it took 14 hours. Now, by doing some quick math, that's going to be 80, and this will be 40. So we have our two equations, P plus W equals 80, and P minus W equals 40. So if we're going to solve this equation, probably best done by the method of elimination. And looks like if we add these two equations as is, our W's will simplify out, and we're left with 2P equals 120. So dividing both sides by 2, we get our plane speed to be 60 miles per hour. To find out our speed of the wind, we can just take this, plug it back into either equation. We'll do the first one. So 60 plus W equals 80. So by subtracting 60 on both sides, W would end up equaling 20 miles per hour.